Hello everyone. In this lesson, we will mainly introduce the definition and application of custom exception classes. Java has defined numerous exception classes to handle various exceptional situations. Here are some common exceptions. Arithmetic exception, thrown when the divisor is 0 or the precision is insufficient to represent the result of the division. Input mismatch exception, thrown when the input data doesn't match the expected type or exceeds the range of the expected type. Null pointer exception, thrown when an uninitialized or non-existent object is accessed, or when accessing or modifying properties or methods of a null object. Class not found exception, thrown when a class is not found. This can occur if the class doesn't exist, the development environment has been modified, e.g., changes in directory structure, or compilation or execution paths, or the class name has been modified without updating the calling code. Case exception, thrown when attempting to cast an object to a subclass that it is not an instance of. Illegal argument exception, thrown when illegal or incorrect arguments are passed to a method. Illegal access exception, thrown when there is illegal access to a specified class, field, method, or constructor. Squall exception, thrown for database-related errors. Exception, thrown when there is a failure or interruption in input or output operations. Although Java defines various exceptions for different situations, it's not possible to cover all development needs. In practical applications, developers may need to define custom exceptions to handle specific circumstances. Custom exceptions need to inherit from existing exceptions in the JDK. In theory, a custom exception can inherit from any exception class. The exception class is the parent class of all exception classes in Java, so it's commonly used as the base class for defining custom exceptions. Let's take a look at an example of a custom exception. This code defines an exception class that represents a negative divisor. This class inherits from the exception class. It defines two versions of the constructor, each using the super keyword to call the constructor of the parent class and construct an object. The code demonstrates the application of a custom exception. It defines a div method that takes two integers as parameters and calculates their quotient. Inside the method, it checks if the divisor b is negative. If it is, it throws the custom exception. The div method uses the throws keyword to declare that it may throw this custom exception. You may consider how to modify the code if you also want to handle the case when the divisor is 0. When using custom exceptions, it's important to note two things. First, it's common to use the if structure and the throw keyword to throw custom exception objects. Additionally, if a custom exception class inherits from the exception class, it falls under the category of checked exceptions. Therefore, it must be handled. Otherwise, it will result in a compilation error. This lesson primarily covered common exception classes, the definition and usage of custom exception classes. In future development, you can apply these concepts based on your specific needs. That concludes this lesson. Thank you. When defining a custom exception class, the class that can be inherited is